Section 9.2 is solving for n in a time value money problem. So 9.2 n. And again, we look at our formula and we said our future value is equal to our present value 1 plus I to the n. Solving the n seems to be a weird problem here. We know that future value over the present value is equal to 1 plus I to the n. But solving for n now, we need to find the logarithm. So n is equal to the ln of future value over present value, all divided by the ln of 1 plus I. We can do this in the calculator, but again, or we can do this as a formula, but again, we probably just use the time value of money formulas inside of our calculator. The big thing here is we're going to get a number of periods n. So the result from a calculator is n. And if we want to convert this in a number of years, we knew we had the formula that says n is equal to years times m. So if we want to solve for years, the number of years that an investment is going to be is equal to n, the value from the calculator, over m, the compoundings per year. Taking a look at this as an example, we'll take a look at question 4 on page 344. So page 344, number 4, it states the current balance on the loan is $38.3730. If the interest rate on the loan is 10%, compounded monthly, how long ago was the $2,870 loan made? So we have a timeline that says the loan started at $2,870. Its current balance is $3,837.30. This is growing at 10% compounded monthly. And what we're looking for is that length of time. So because this is a loan, I'm going to make the assumption that we made the loan. We have to owe money. So if we have to owe money, we got the benefit for the money here, and we'd have to pay for it at the end. So I'm going to set that value to negative. If we were the bank or the lender, then this would be negative because we'd have the money out right at the beginning. So as we look at this, our present value, this is $28.70. Our future value is negative $38.3730. Our interest rate per year is, well, we still have to calculate I is equal to J over M. That's equal to the 10% divided by 12. Got a good spot for this. 10 divided by 12. We have a value of 0.833. If I look at 0.833, what I really want to do is I'm just going to store that directly into I per Y. So it's a stored value. We're now going to compute the value of n. Put the values into the calculator. Okay. So we're saying 2870. This is going to be our value of our present value. 38.3730. This is going to be our future value. We already have our I in. We're going to compute the value of n. 38.37.3 negative in our future value. Compute n, and n is going to be 34.999. This is essentially 35 periods. And we know that our periods we can convert to years. We say n is equal to years times m. And because this is monthly, years is equal to n over m. N is the value we got out of the calculator, so 35 periods over m, which is 12 times per year. This is equal to 2.9166. years. If we want to convert this into total years and months, we would say this is 2 years and 0.9166 years. Then we can convert this value into months. So 2 years plus 0.9166 years times 12 months per year. In this case, that year cancels out that year, and what we get is, well, we had 2.9166. We're going to subtract off the 2, so we have 0.916667 times 12. That's exactly 11 months. So looking at the problem, we say the loan was made two years and 11 months ago. So the big thing for calculating n is that the resulting n, so computing n in the calculator gives us a value of periods, gives number of periods. Okay. Step one is that we're going to say n over m, it equals number of years. And then we're going to take the number of years, we're going to subtract off total years or full years. And then we're going to take the remaining portion of year and multiply by either 12 for months or 365 for days. And the thing is, if you want your result in days, so if this is the value that you're going to do, don't do months and then days, do 365 days, and then you would use a date table to determine the months. So if you're really looking at days, use the days, do all the stuff that we did before when we looked at simple interest. So do question 10, A and B. So question 10 on page 344. We're looking there as we're saying, round to the nearest month, how long will it take an investment to double if it earns 8% compounded annually? So we're looking at investment and we're finding how long it'll double. Well, we don't have numbers here, but we can say this is -1 and this is 2, and that would be taking $1 and converting into $2. We could also say this is $1,000 and this would be $2,000. Any value where here is going to double over time. in first problem is we're going to say 8.4% compounded annually. So if we say the rate is 8.4% annually, fairly simple problem like we had before. We said present value equals, we'll say -1, future value is equal to 2. You could also use 1,000 and 2,000 if you wanted. Our I per Y, because it's annual, this is just 8.4. And we're going to compute N to be 1 negative present value, 2 future value, 8.4 I per Y, compute N, and it says 8.5936 years. It's going to take 8 years to do this. If we do the math here, this is going to be 8 full years, so we're going to subtract off 8. So it's 8 years plus 0.5936 years. If we want this into months, if we want to do this calculation in months, we take the 0.5936 times 12, and that equals 7.124 months. If we want to do it in days, we do 0.5936 times 365. Okay, so 0.5936 times, we're going to multiply by 365, and we get a value of 216.68 days. So we say that's approximately 217 days. If this is starting at the beginning of the year, we would say 8 years down the road, and we could take a look like we did before on page 203, find day 217. So if it started on the 1st, we'd say it would be August 5th. If it didn't start on the 1st, we could figure out exactly what the day was for it. We're going to take a look at the other rate. The other rate for the question is 10.5% compounded semi-annually. So again, we have the same values. The values that are already in, we'll put in green. Present value is -1. Future value is 2. Those aren't going to change. The I per Y is, the I per Y now is not just 10.5%. We'll calculate it. I is equal to J over M. This is 10.5 over 2 because it's semi-annual compounding. So this is 5.25%. We compute the N, and the result of this is going to be 10.5 divided by 2, I per Y, compute N, and it says 13.546 periods. This is 13.546 periods. Well, it seems like a longer amount of time than we had before. But these are half-year periods. Half-year periods. So what we have to do is we have to say years is equal to N over M. So this is the 13.546 over 2 because it's twice per year. So the number of years is equal to divided by 2, 6.7732 years. Notice, first of all, that a higher rate meant a shorter amount of time to compound. Second thing, again, we're going to minus the 6, minus 6. So we get the 0.7732. We're going to multiply by 12, and that equals to 6 years, 9.28 months. Or 6 years, if we multiply by 365, would be 6 years, 282 days.